Imagine a hidden force lurking beneath our oceans, capable of drastically altering Earth's climate in ways that could outpace even our worst emissions nightmares. This isn't just science fiction. It's a startling discovery about a supercharged thermostat that might make the planet overcorrect for human-induced climate change, potentially bringing the next ice age right on schedule, instead of postponing it by thousands of years. Intriguing, right? Let's dive deeper into this fascinating yet complex topic, breaking it down step by step so everyone can follow along. At the heart of this revelation is the massive amounts of carbon dioxide, CO2, we're releasing into the atmosphere. Scientists have long known that Earth has natural ways to balance this out. But what if one of those mechanisms is more powerful than we thought? Researchers have uncovered a second thermostat that could efficiently bury enormous amounts of carbon deep under the seafloor, potentially neutralizing human emissions within about 100,000 years. Picture this as Earth's built-in cleanup crew, working overtime to scrub the air clean. But here's where it gets controversial. This newfound thermostat, when teamed up with the one we've known about for decades, might not just stabilize things. It could overshoot, kicking off the next ice age exactly when it was supposed to, without the delays we've anticipated from climate change. Study co-author Andy Ridgwell, a geology professor at the University of California, Riverside, shared this with Live Science, pointing out that both systems operating together could keep glacial cycles on track. For context, previous studies suggested climate change might postpone the next big freeze, due around 11,000 years from now, by up to tens of thousands of years. Yet this organic carbon thermostat could bring it back on time. Now, before you breathe a sigh of relief, thinking this saves us from immediate global warming woes, let's clarify. This discovery doesn't shield current generations from rising temperatures, extreme weather, or other impacts. As co-author Dominik Hulse, a mathematician and biogeochemical modeler at the University of Bremen in Germany, explained to Live Science, we're not safe from global warming in the next century or even millennium. This is a geological timescale fix, not a quick fix for today. To understand how Earth's climate regulation works, think back to the 1980s when scientists first theorized about something called the silicate weathering feedback. It's like a basic thermostat that helps control atmospheric CO2 over millions of years. Here's how it functions in simple terms. Rain in the air picks up CO2 and carries it to rocks made mostly of silicate minerals, oxygen and silicon compounds that form about 90% of the Earth's crust. The CO2 reacts with these rocks, breaking them down and turning them into substances that filter into the soil and rivers, eventually flowing into the oceans. There, they solidify into limestone and chalk, locking away the carbon for eons. This process acts like a climate regulator. More CO2 in the air warms the planet, speeding up the water cycle and increasing rainfall. That, in turn, ramps up the weathering of silicates, pulling more CO2 out of the atmosphere and cooling things back down. Conversely, if the planet cools too much and CO2 levels drop, less weathering occurs, allowing volcanic and mantle releases to gradually bump CO2 back up. It's a slow dance of balance, but it can take up to 1 million years to kick in after a major disruption. And this is the part most people miss. Despite its elegance, this silicate thermostat alone can't account for all of Earth's wild climate swings. Like the dramatic glacial interglacial cycles every 100,000 years, with huge shifts in CO2 and temperatures. It also doesn't explain extreme snowball Earth episodes, where the planet freezes over completely. If silicate weathering were the only player, these icy extremes might not happen at all. Enter the second thermostat, supercharged and rooted in something unexpected, Earth's phosphorus cycle. This idea sprang from Hulse's PhD work, where he analyzed how organic carbon gets preserved in ocean sediments during past climatic upheavals. He found that after intense volcanic warming, massive deposits of organic carbon piled up on the seafloor, hinting at a connection between CO2 levels and ocean carbon burial. Ridgwell and Holzek combined forces, merging their research into a comprehensive model of the global carbon cycle that includes this seafloor burial. What they uncovered is a thermostat powered by phosphorus, starting on land with rocks rich in minerals like apatite. When it rains, these rocks weather, releasing phosphorus that washes into streams, rivers, and ultimately the ocean. In the sea, phosphorus acts as a vital nutrient for tiny photosynthetic organisms called phytoplankton. These microscopic plants use phosphorus to grow and perform cellular tasks. When they die, they sink to the bottom, depositing organic carbon, phosphorus, and other elements. In a warning world, more phosphorus floods in, boosting phytoplankton populations and burying even more carbon. Here's the twist. Warmer oceans dissolve less oxygen, leading to deoxygenation that releases buried phosphorus back into the water, while the carbon stays locked in sediments. This recycling creates a boom in phytoplankton, which greedily absorbs CO2, pulling it out of the air and cooling the planet. It's like the Silicate thermostat on steroids, where phosphorus lingers in the ocean longer even as temperatures drop, fueling continued productivity. The potential for overcorrection is real. As Ridgwell describes it, this organic carbon thermostat is similar to the Silicate one, but with a supercharger that floods the oceans with nutrients, making it hard to dial back. This imbalance could trigger extreme events like Snowball Earth in the past, though today's oxygen-rich oceans make that scenario unlikely now. Instead, the question is, could this mechanism counteract the delays to the next ice age caused by climate change? Human activities are already messing with natural cycles, and studies indicate emissions could postpone glaciation. But if this thermostat kicks in, CO2 might plummet faster, setting the stage for an ice age right on cue. Whatever delay we'll see for the next ice age, this mechanism might pull it forward, Ridgwell notes. One thing's certain, it's coming. It's just a matter of when. This discovery sparks some heated debates in the scientific community. Are we underestimating these natural feedbacks, potentially giving humanity a false sense of security about long-term climate impacts? Or could this overcorrection lead to unintended consequences, like abrupt cooling that disrupts ecosystems and societies? What do you think? Does this mean we should rethink our approach to emissions, focusing more on immediate actions rather than relying on Earth's thermostats? Share your opinions in the comments below. I'd love to hear agreements, disagreements, or fresh perspectives.